Okay, so this will be going back to review for the transistor. Okay, I said revision A. That means I delete something, adding something else. Okay, and quickly go through that. So this one is, we already done it, okay? So we don't have to do anything. Just few things we want to emphasize. You see that last time I saw the meter tie try to go over how to doing a calculation, but it didn't. Not really good the DC bias configuration. So that's why I not pay any attention. Okay, just let you know. Now this one is the one he's using everywhere all the time. Okay, and I try to make sure you get the formula. Okay, how to calculate the VE, IEIB, IC, or VC, VRC. Okay, now this is the one I want to bring it up today. Basically, in order to calculate the VBB, that means the voltage right here. Normally, you're using the voltage divider, R1 and R2. So basically, if you want more accurate for the value of the VBB here, then this is the one they given to you a little more detail, but you don't have to go too much in detail here. If the base current IB is much smaller than the current I2, that means the current going to IB here, okay? Much smaller than the current I2 right here. Then you can using formula VCC times R2 divide R1 plus R2. That means only R1, R2 divider. However, if you want more accurate for the VB, then that's why you have to do if IB is not small enough, you need to compare to I2, therefore more detail calculation needed. So that they telling you, you need to calculate the resistance from here to the round. That's what they call R in base. So if you calculate the R in base here, that will be telling you R in base and R2 in parallel. Okay? So you have to calculate that combination before you can calculate the voltage divider. And we already showed you here. Okay? VB base will be equal. That means the voltage at the base here will be equal 0.7 right here, adding to the voltage drop across RE. Okay? That's why they say VBB at the base equal VBE 0.7 plus IE times RE. Okay? And IE times RE assume IC, IE, very, very close. Okay. So that's why you can calculate the VBB equal IB times RE. And I in B will be VBB divided to IB. Okay. The total resistance from the base to the ground are 2 parallel with R in base. And the formula now you can see the difference. This is the formula. That means VBB equal VCC times R2, okay, parallel with R in base divided to R1 plus R2 parallel R in base. Okay, that means a little more calculation. However, really we don't need it, I can tell you. For example, VBB equal 10 volt. We are testing. We not design anything. Okay? So when they asking you to measure VBB 10 volt, nowhere you can get 10 volt. That's why they need to get a tolerance. Okay? Have to be plus or minus, for example, 10%. So 10% of 10 volt, then you can get the upper limit. Will be 10 volt plus 10% is 1 volt, right? 10% of 10 volt. That means 10 times 10 divided 100, 1 volt. So up will be 11 volt. And the lower, 10 minus 1, 9 volt. So when you measure, if you get a voltage between 11 and 9 volt, you will be okay. So that's why if you calculation with this formula, you can get more accurate for value of VB, okay? But really don't need it, okay? So that's why I just show if maybe you go to the college university, they will be asking you to do it. But we are technicians. We are just testing, okay? Then we don't need that.
Mr. Fan, before you go to the next slide, can you clarify what those question marks are for each one of those formulas?
Okay.
Please.
Yeah. IB. Okay. Let's see.
IE times RE.
VBB divided to IB, right?
Is it better?
Right here. VBB divide IB. That's clear. Okay. Now to try to see what's going on this line right here. The question mark here. What is it?
Should be beta.
Beta. The thing I don't know why on my iPad they don't want to display that. So basically that will be IB right here.
Each question mark is considered beta then. All right, thank you.
Okay. So beta IB times IE. Okay. So beta VB, V at the base, that will be a beta here. Beta IB times IE. Okay. And that will be IB cancel out. So you can get only beta RE. Okay. So basically, you need to calculate the actual parallel with our base. Then you can apply the voltage divider. However, if you download your handout, you don't have any problem. The thing I did, my iPad gave me a problem. Also, I not try to go in doing calculation here. We already done it. You have to know how to do it, okay? If you get a question, then just let me know. On this PNP, I already given you the formula here, okay? Remember, uh, when you get a question mark here, so basically that's just a beta, okay? Next time I better time type beta instead using this symbol, okay?
Question, Mr. Bell?
Yeah,
If you can go back to the slide where you substituted the beta, the equation for, go back some more. There, yeah. On the equation where you have, oh, okay, it's Rn. All right, my mistake.
okay.
Rn is equal to beta R. All right.
I have a question. You haven't necessarily gone over it here, but I was confused in it in the equations. What does R apostrophe E stand for?
Which one you asking about? This circuitry or previous one? Which one?
One second. Let me.
It was one of the equations. I believe that was a mistype.
Yeah, and so it happened here a couple times on. I'm at slide 34, and it says R apostrophe E equals 6.58 ohms, and I just wasn't sure what that meant. R prime. Okay. I'll go look that up. Also, would there be a way that you could go over AV voltage gain?
Now that's what you're talking about AC, right?
I believe so. It was in a homework question, and I didn't understand it, so I was just wondering if you could go over it. I believe so.
Okay, now for this pay right here, any question to do your calculation? If it's not, we can go. Also, the next one. Everything we will already get a formula here. Okay? Then, if you cannot get through it, then let me know. And this is a PNP and already given to you on up the formula. If you want it, then I can go over. Okay? For example, that's just a voltage divider. Okay? You want to calculate that one. I want you to using R1R2 in voltage divider. We don't need to doing calculate the R in base and parallel with R2. That takes too much labor. Okay? And after you get the VBB here and the VE, VE that means the voltage right here. Okay? They will be VBB plus 0.7. IE will be VE divided to RE. IE divided beta plus 1. and IC equal beta time IB. Why on beta on this pair they display, on the other pair they not. Okay, so now we go into the AC module. That's a coupling. That means the capacitor for AC they shorted. DC they will be open. And they show you how they will be short, how they can be open. Shorted means they allow the current flow. Open means no current can be flowing. Okay, so make sure you understand for AC analysis, capacitor is shorted. And DC analysis, capacitor will be open. Okay. Now, for students want to understand a little more on the AC module, you must be following this standard here. Okay. You want to doing a AC circuitry. First thing you have to be make sure you get complete DC analysis. That means without the DC voltage, transistor cannot be working to make an amplifier. And also, I want to make sure, okay, you're following the rule here. If I say VB, VC, VE, VCB, for example, and also I say VB, VC, VE, VCB. Then you understand it that for DC, and that will be stand for AC, like IE, IB, IC, that's the DC, capital, IE, IC, IB, okay? That will be AC, same thing. RB, RE, RC, DC, RB, RE, RC. That will be for AC. Okay? Otherwise, when you're reading, you don't know which register. So, in order to convert into the AC circuitry, then in the AC circuitry, you cannot see any capacitor. The thing is, capacitor will be shorted. And also on up the DC power supply, you must be shorted to ground. Then you replace the transistor by pi or T module. Okay, that means you must follow that. Now, this is a transistor in the AC. This will be collector, this will be the base, and this will be emitter. Instead, you draw this transistor. You not draw anymore. You draw from the collector, go into the base right here. You get the current IC, current source right here. Okay, and from the base to the emitter, you don't see any more diode. You substitute by R prime E. That means Now there will be a resistance from the base to the emitter, and will be calculated by this formula for the transistor. Okay, they make the transistor, they make it. Okay, we don't make it. We cannot get. Okay, and now let's see for this one here. Okay, we already see when you apply input into the base, output from the collector, that will be common emitter. Okay, common emitter, that's telling you emitter will be go to the ground for the AC. Okay, and the C1 here, C2 here, that they get the name DC blocking, AC coupling. C1 here allow the sine wave to go in from the input go to the base. However, in case any DC from the input here cannot go to the base, you don't want any DC for your signal. And also at the collector here, you can get a DC for the collector when you will calculate the DC. And also you can get the sine wave. So when you go into the output here, that means you go connect to the load. That will be speaker. Your voice, you want it to go to the speaker, you don't want DC here. So that's why C2 will be blocking this DC, but allow the signal to go. And also this capacitor here, what is the name?
Bypass.
Bypass. Okay, make sure when you don't have to memorize everything, but at least minimum thing we must be know. C3 they call a bypass capacitor right here. Bypass what? Will be bypass this resistor. So AC current go here. IE. When they get into the base, they go this way, to the route. They not go to RE. So that's why they bypass that resistor. Okay. So why do we need the bypass capacitor here? What affects the bypass capacitor to the amplifier?
Increase the gain.
Perfect. Increase the gain. Without the bypass, the gain will be lower. Okay? That's what I want to do. And also, it's a picture here. Okay? And they're telling you what the signal will be look like. In here, you get a 100 microvolt, okay, IMF, that means your voice, okay. When they go into the base here, you get 2 volts. One will be DC 1.8 volt, and one will be the sine wave, 100 microvolt IMF, okay. And when you're looking at the point right at meter right here, AC, that means at this point, you can get a VE equal 0 volt. The thing that they shorted to route. However, you still get the DC voltage here, 1.1 volt, when you calculate the DC. Also at the collector, you get 2 voltage. One will be DC, and another one will be your voice, sine wave. However, now they're bigger, but they will be opposite to the input here. Input going up, output going down 180 degrees or phase or opposite. Okay, when they going out to the load here, capacitor C2 block 6.04 volt. Your voice will be going only sideways. So that's why in here you can see, if you're looking on the scope, you can see right here 6.04. However, at the output here, this must be 0. Okay, so when you try to working with this transistor, when you measure the AC, you must set your oscilloscope to AC coupling. They block the DC, so you're able to measure your AC voltage. Otherwise, no way. The thing is, 100 microvolt compared to 1.8 volt, you cannot see your sideways. And now, they completely converted into AC. This is a transistor right here. That is the base. That is the collector. And this is the admitter. You see that the admitter routed. That's why they call a common admitter. If common collector, then collector will be round. Common base, and the base will be round. Okay, and you can see you can get a R1 and R2 will be parallel. Okay, and also RC and RL also will be parallel. So now what you need to do is you can calculate the RC. Now if I say I want RC, C lowercase, what equal?
Parallel RC capital, RL capital.
They're telling you they want the AC resistance at the collector. And at the collector, if you're looking into this way, you can see RC parallel with RL. Some different textbook, they can say that can be the output impedance. Or some textbook, they can say RL. That means load resistance, either way. But we're not using this from now on. We'll be using RC. Okay? That means output impedance. Input impedance, that means your source right here. You're looking into the amplifier. That's what they call R. E. Okay? Then you can see you get the R1 parallel with R2. And also you have to get the one resistor from the base to the ground. That's what they call now we're using same thing here. Easy to recognize. R. B. Okay? So input impedance, R in will be equal to R1 parallel with R2 parallel with RB. Okay, and we have to calculate RB. Don't count on this guy, okay? This inside the transistor. If you want to calculate the gain, and they gave you the gain right here. RC, okay? See that data from the textbook? They using RC here. We using RC. Okay. R prime E. Okay. Then basically they can get R prime E. Same thing. Now, if you want to calculate the gain, okay, AV, what AV equal? Voltage gain
V out over in.
equal what? V out, right? That means right here. Divide what?
V in.
Now, that is misunderstanding. They must be divided to VB. Right here, AVB. However, in this case, you can see V in and VB will be the same. Right? V in here or VB here will be the same.
Right.
But by basic definition, they must be V out divided to VB. How come? I can tell you. If you get a one resistor here, they call a RS, for example. Then VB and V in, they're not the same. They will have to using the voltage divider to calculate the VB. Okay, so when we get one of the problem, I go to detail for you. But what I want you to make sure, if you're doing a calculation the gain for the transistor, they have to be ratio between V out and VB. Okay, not V in. If the in case V in or VB the same, that be fine. Sometimes they not. Okay, so basically here, you can get a sine wave coming in and you get the output will be inverted. And this one, if they want to calculate for the DC, okay? Everything we already get through it.
Mr. Pham,
Yeah.
your question, what is the advantage of the T model when we're analyzing the amplifiers circuits? Why we need this T model?
Why do we need what? DC or what?
No, the T model. Why do we need to use a T model to analyze this amplifier circuit?
Oh, without that you cannot. That's just a formula. You want to analyze AC, you have to using T module. That's it.
Okay.
Okay, you have no choice.
Mr. Pham,
Yeah.
I had a basic question on that one you passed up. The R prime E was in parallel with those other resistors, and you said the R prime E was inside the transistor, but still, since it's in parallel, how come you're not using it? Is it that the value of R prime E? Yeah, right there on this one. Is it that the value of R prime E is so small that?
Okay. No. The thing is when you calculate the RB, they will include the R prime E.
Okay, let me just finish this. The way I'm looking at the drawing, I see R1 in parallel with R2 in parallel with RB
Right.
in parallel with R prime E.
Now, the thing is what I'm saying is RB that will be including R prime E inside the transistor when you do your calculation for RB.
So ignore R prime E and just...
Now that's already including RB.
Okay, all right, thank you.
Yeah. Okay, that one, they calculate the DC and they calculate for the AC. Okay. CC amplifier. Get another name, admitter follower. Collector is at AC route. Stable voltage gain. High input impedance. Low distortion. Okay, so this given to you when you're looking into the circuitry, even you don't know detail to calculate inside, you must recognize what type of the amplifier. Input connect into the base. However, output from the admitter. This is the admitter. So that's why they call a common collector or admitter follower. They're telling you V out the same with the VE. Okay? That's why they get the name admitter follower. Input applied to the base, output from admitter. C1, C2 is DC blocking. And also input and output, they will be in phase. And this one they draw it, okay, for the D module. This is a collector, you see they routed here. See that? Common collector. This is the base, and also it's the admitter. This will be inside the transistor. Okay? Outside, you can get the R big E and also R load. Okay? That one here, right? R load right here. So R big E and R load will be in parallel. Okay? So that's why they say RE here. RE here, E lowercase, telling you admitter resistance for the AC. They will be equal to R big E parallel R big L. Okay? And also they given you R in. That means the input impedance will be R1 parallel with R2 and also parallel with R in base. That means you have to calculate the R in at the base from the base to the route. Okay? And when you need to doing a calculation for the gain, then they will be equal to R small e divide R prime E plus R small e. Okay? This one you need to make sure you get a note when you do the quiz. Okay? You have to using the formula. You have a no time to open your handout. Okay? And this is a CC calculation. Okay? You have to go through that. At least, few times to know how to calculation. And also this one here. Now, if I draw this circuitry different, okay, I want to ask you that input coming in, okay, and basically this transistor here. Big E, V out, okay. My question is, if I want calculate RE, what RE equal?
R big E in parallel with RL.
No, we don't have a IL here.
It's RE, big E.
Exactly. If you get the load, then they will be parallel.
Oh, yeah.
Okay? However, we don't have any load. They calculate the R small e. Then if this is a 1K, then this have to be 1K. Otherwise, when you do the left, I guarantee you do the quiz, you get the wrong answer. If you keep apply the formula without understand, okay, same thing. Man.
Are you saying that's the output resistance?
How that will be output resistance.
I thought for the emitter follower, the output resistance was RE over beta.
You mean common collector. Output resistance equal where you get
Common collector is the emitter follower, right?
emitter follower.
Yeah.
Okay, so you get the output impedance. Where we are now? Common bay. Okay, common collector right here. Okay, they already given to you. Let's see. R in RE. Right here. For this circuit. Okay.
So the input is beta RE.
Input at R in beta RE.
And the output, okay.
That beta. Okay. Now, if I get this circuitry here, okay, so if you're looking on the circuitry, what's the name of the amplifier?
Common emitter.
Perfect. CE amplifier. And I want to know what C. That means collector resistance in AC.
Yeah, it's that resistance right there.
Equal what?
The same RC.
Equal, right?
Right.
Not parallel with a load. The thing is we have a no load. If you get the load resistance here, then they will be equal R big C parallel to a load. Have to be understand that. Okay, then you get a common base and everything will be already showing up here. Input, output will be in phase. Okay, and also they give it to you the gain equal RC divide R prime E parallel with R big E. Okay, this is your calculation. This is what we're adding to you. Summarize, okay, for the common admitter. Input is at the base. Output is at the collector. There is a phase inversion. Input and the output. C1, C3 are coupling capacitor for input-output signal. C2 is admitter bypass. That's C2 right here. All capacitor must have negligible reactant at the frequency of operation. Admitter is at the route, AC route, due to the bypass capacitor. Okay, so when you keep reading over and over here, you get to understand for the common basic admitter. And this is the formula. Okay, if you want to calculate the VB, in here they say R2 parallel with beta time RE divide R1 plus R2 parallel beta RE time VCC. That means they go to more detail. You can using this formula or you can using R2 divide to R1 plus R2 time VCC. The answer will be very close. And if you want to calculate the VE, VB minus VBE 0.7 volt for silicon, IE equal VE divide RE, and VCC, VC equal VCC minus ICRC. Okay? This one I given you another formula. Simple. VCC times R2 divide R1 plus R2. Okay? And this is the AC here. They give it to you. R prime E 25 millivolt divide IE. Okay? R in equal beta times R prime E. R out almost equal RC. That means they have a no load in here. Okay? The gain voltage will be equal VB over VS. Okay? Time AV. That means they can get a resistance RS. Okay? And the current gain and the power gain. That will be common collector. Input is at the base, output is at the admitter. There is no phase inversion. From input to output, they are in phase. Input resistance is high. Output resistance is low. Maximum voltage gain only 1. Collector is at AC route. Okay, same thing. And this is they given you the formula. Okay, and you can see how you get the gain. Okay, AV equal RE divide R prime E plus RE. Okay, and R in base equal R out equal. Okay. And the last one, voltage divider for common base. Okay. So you can see common base or common collector, they have a no gain. They will be a 1 or less than 1. And the common base input output will be the same phase. Only the common collect at meter, you can get more gain. However, input output will be inverted. If they want more gain, then they can using common at meter. Okay. Otherwise, if they want more input impedance or more output impedance, then they have to using common collector and common emitter, a common base. Common base, they say input resistance is low, output resistance is high. Okay. However, common collector, they get the input resistance is high and output resistance is low. That means they give another two amplify C and CB. In case they don't want the gain, they want the impedance, input impedance, output impedance. Then either one, they can know which one to use it, okay? And this is the formula for the AC. We already get through it. And this one also by Darlington connection, Darlington pair. They try to increase more current gain. The first, you get a beta 1. Okay? You understand the formula will be IC beta 1 times IB. Or they can be equal beta Q times IB. So if you get a beta 1 100, beta 2 100, so the current gain will be very, very high. Okay? That's it. Any question? You normally from now on to the end of the semester, you get only quiz on Wednesday. Okay? And after the quiz, you have to upload right away the reporting. If next day you upload it, you get maximum will be C. Everyone supposed to do it, okay? So any question? Otherwise, we can go to another one. Today, I try to get through the review for the transistor. Then the next one will be Decibel. Okay? So now we will be go into...
Hey, Mr. Pham, quick question.
Yeah, go ahead.
Will you be giving the class like a heads up on what the quiz will entail so that the students can study for it?
That's what I just go to it.
In other words, if you're going to give a quiz on Wednesday, will you say ahead of time what it's going to be about?
That's what I just said. I just go through for you.
Okay, thank you.
Transistor.
Is it going to be a quiz or an assignment? So it's like we don't normally upload quizzes, right? But we do upload assignments.
You mean on the quiz?
Yeah, the quiz is going to be an assignment.
No. On the quiz on Wednesday, I will be let you download the quiz report. Okay? And then you can follow the question. Okay, number 1, A, B, C, D, or whatever. Then you have to enter on that. Then after done, you upload right away.
Okay.
Okay, so we're going to download a quiz and then we're going to upload it.
Right.
Oh.
Download to report. You have to typing in for your selection. Number 1, A, B, C, D. Or number 2, whatever. And after you get, normally you get 15 questions. That takes about 15 minutes. Then you save it, upload it right away.
Oh, what day is this going to be?
Wednesday.
Okay, Wednesday. Thank you.
They have to be concentrate on the transistor. Take one. How come I don't have it? Just wait for me a minute. I need to. Okay, let's see. Okay, I can using my desktop. Okay.
I just had a quick question, Mr. Pham. The Darlington transistors, is that also known as the Darlington pair?
Yeah. Normally, you can build it using 2 transistors, or they already built inside one packet.
You can also use more than 2 transistors. I think they do that in operational amplifiers. Is that correct?
Can you say again?
Yeah, in operational amplifiers, which we're going to get to, I think, this week.
No, that's only one they're using when they want to get more current. Nothing to do with the amplifier. You want to get more current, so they can add in that circuitry. Okay, Decibel. Just a minute, I need the notepad so I can have. Okay, the decibel unit is important in amplifier measurements. The decibel is a measurement of the ratio of one power to another or one voltage to another. And power gain is expressed in a decibel. AP equals 10 log of AP. Voltage gain expressed in a decibel. AV will be 20 log. Okay, now we'll see. You get AP. AP equals P out.
We can't see your notepad, Mr. Pham.
No, I will be bring it there. Divide QP in. Let's see. Can you see that?
Yes.
Okay. Just a minute. I try to make it so that I can see it. Okay, AP, that means P out divide QP in. Okay. AV, that means basically definition V out divide UV in. However, if you want to doing a calculation of power gain or voltage gain or current gain in a decibel, then the formula, okay, AP, now they have to be in dB, decibel, okay, will be equal 10 times log okay, up VPL divide QP in. Okay, and if you want to calculate the voltage or current, then they will be equal AV in dB. The difference will be 20th of V out and V in. Okay, now I gave it to you. I given AP equal 0.707. Can you tell me AP in decibel equal? Using your calculator. Equal what?
Minus.
Okay, let's see. You take the log of 0.707. Equal times 10. Is it a minus 1.5?
That's what I got, 1.549.
Minus, is it right?
Correct.
Okay, the answer will be minus, okay? 1.5.
When you take the log of 0.707, the first thing you get is a minus number, and then it's times 10.
But it's log to base 10. You have to remember it's log to base 10.
سلام غذا آماده است گازه.
Okay, what you need to do, okay? Basically, you can say AP equal, okay, AP dB, decibel equal 10 times log of 0.707. So that's why they given to you minus 1.505. Any question how to doing calculation?
Far so good.
Okay, now I want to doing calculation for me. A, P equal 0.5. Okay, calculate AP in dB.
-3.
If I give an AP 0.5
Is it negative 3.1?
minus,
3.01.
if you're doing a calculation right, minus 3.01, right? dB. If you not follow it, let me know, okay? Otherwise, it's too late. AP equal 0. Okay, equal 1, sorry. I want AP dB.
Is it
0? 0.
0. Perfect. dB. Now, now 0 dB, what that mean? Okay, now you can see AP equal P out divide to P in. And now they equal 1. Okay, that means P1, P in equal P out. Now,
I'd like to ask the class a question. How many people understand logarithms?
I have no idea what a logarithm is. I know if I put in log on my calculator, it works, but I have no idea why.
right.
Yeah, so
That's just a formula. You want to doing your calculation for the log. That means you have to know how to using your calculator.
Hey, Mr. Pham, can I ask you a question?
Yeah.
What you have on the bottom line, you have AP equals P out over PN. And so P out over PN is equal to 1. Is that what you're saying?
Right. That's what I say. AP on the first line. Before that line, I say AP equal 1. Okay.
So if you take the log of 1, that's 0.
Right.
Okay, thank you.
But I want to make sure you understand. AP equal to 1, and I doing calculation for the dB. I get 0 dB. I try to explain to you. When you try to get the 0 dB, what that mean to you? Now I given you a little detail here. AP equal P out divided to P in equal 1. That mean input output the same, right? Input and output the same. That will be no loss. Input coming in 5 watt, output 5 watt. That means you don't have a missing any. Okay, 0 dB, the ratio between the output and the input, if they equal 1, that means you have a no loss signal. Okay, so for the dB, any number less than 1, they will be get a negative dB. The thing is you lost. Okay, if you get a positive, mean you get a high gain. Now, I given to you AV equal 0.707. Okay, and I want that AV in dB. The formula will be 20 log. Okay, so if you're doing a calculation, what you get?
3.0.
That's 3 dB because
minus
20 minus 3 dB.
You must know how to do your calculation.
Minus 3 dB.
Minus 3.01 dB.
Same thing. Minus 3.01 dB. Okay, so that is telling you if you get the decibel, all the time they will be a the ratio between output and the input, either for the power or the voltage or the current. Voltage and the current will be using the same formula, 20 log. Only power, they will be 10 log. That's a difference. Okay. The maximum gain equal a mid-range gain and is a size 0 dB value. So at the mid-range, what's the relation between V out and V in? What is the mid at the, what is the V out over V in for the mid-range?
No idea.
No idea.
I think the students need to understand what a logarithm is.
They say maximum gain equal a mid-range gain and a size 0 dB. My question is, if you get them at the mid-range, what the relation between input and output be?
They're the same.
They're the same, perfectly. The thing is, 0 dB means 1 decibel, right? Equal 1. Okay? If the gain equal 1, input output will be the same. So make sure you understand if they're talking about the mid-range, that's only telling you at that point input output will be the same. No loss, no gain. Next will be the critical frequency. Also, they can get a different name for the same thing. They call a cut-off frequency, corner frequency, or break frequency. At this frequency, output power drop to 1/2 of its mid-range. Okay, that means if you take a APDB 10 log of 0.5, how come they're using 0.5? You know the formula to calculate the dB for power will be 10 log. My question is how come they're using 10 log of 0.5?
No clue.
No clue. You can read in here.
Is mid-range.
No, right here.
Off.
Oh, yeah, 1/2 is mid-range, yeah.
1/2 means 0.5, right?
Mr. Pham,
yeah.
I think half of the students in this class don't know what a logarithm is. And they're confused by this. They have no idea what log of a number means. Could you explain that?
You mean log here?
People don't know what logarithm means.
I don't want to make it.
No, we don't.
Where is it? Where is it going to be?
Logarithm is the exponent of the power of 10. The logarithm of the number 10 is
10 power.
is the power of 10 to get that number. So the logarithm of 10 is 1, because 10 to the 1 is 10. The logarithm of 100 is 2, because that's 10 to the 2. The logarithm of 1,000 is 3, because that's 10 to the 3. You have to understand that this is a way of converting big numbers to small numbers in a way. It's
right.
And you have to understand the law of exponents,
right.
which means that you allows you convert because decibel is a power ratio, but to convert a voltage ratio to a power ratio, because voltage or current is the square in power calculations, then you have to understand the law of exponents. So I understand why people are very, very confused by this.
Now, the thing is right now, okay, if you say, we say a log of whatever number, I want you able to doing a calculation with your calculator, okay? When we go in little down here, you can see that will be a log of 10 whatever power, okay? So if I say I want 20 log 0.707, and you're able to calculate for me, it's
that's so small. It's a 2 by 2.
And a 3. Okay. And now dBm, power measurement. A unit that we offer.
Mr. Pham, I have a question.
Yeah.
She's so fucking over. I know he takes my ass everywhere. And for being a little fat shit, she's fast as fuck.
Mute.
Mute the mic.
Man.
Okay, question, go ahead.
On the calculator, can you just walk us step by step how to push the button? Do you just go 10 and then log and then you multiply?
Basically, that will be 10 times. Okay, basically 10 times.
Do you mind if I try to answer her question? Because I think I know what she's asking.
Okay, go ahead.
So for my calculator, I just put in what the log was, which was 10. Then I pressed the log button, and then I just added the number, whatever the number was, and it gave me the right answer.
Thank you.
I didn't.
Thank you. That's
on my calculator, I put log first. Then I type in the number 0.707. Press equal, then I time 20.
Okay.
Yeah.
Let me try it both way then and see
Yeah.
what calculator does.
Depending on your calculator.
Okay.
What type of calculator does she have?
I'm using the computer, but the scientific one, the scientific notation on the computer.
Okay, you can try. Make sure remote know how to do that calculation.
If you use the one on the, yeah, if you use the one in the computer, you type in 0.707 and then push log, and then you multiply by the 20. Do you get that, Sophia? Oh.
Yes, I got it. That was Ababa. Thanks.
Oh, sorry, Biba.
It's okay. Thank you.
Okay, dBm, power measurement. A unit that is often in measuring power in a dBm. The term dBm means decibel reference to 1 milliwatt of power. Okay, now I try to explain a little more for you. When you're working on the radio frequency, IF, normally they're using equipment to measure the dB or dBm, okay? They not measure the watt or kilowatt, okay, whatever. So, working with the equipment, you get the value will be dBm. However, deal with the outside, they want to know in watt or milliwatt, not dBm. So that's why they say the term dBm means decibel reference to 1 milliwatt of the power. When dBm is yield, all power measurements are relative to reference level of 1 milliwatt. Okay, and the formula converting dBm to watt. dBm equals 10 times log of whatever power divide to 1 milliwatt. That's the formula converting from dBm to the watt or milliwatt. Now, I given you example. 30 dBm equal to how many watt? Okay. First thing, you get the formula dBm, okay, equal 10 log of P over 1 milliwatt. That's just the formula. And they given to you equal 30. You get that? Now, after that, I want only log, not 10. Okay? Log of P over 1 milliwatt, they will be equal 30 divide 10. You get 3. Okay? Now you have to remove the log into the log. I take the log out. Okay? On this side, you can get P over 1 milliwatt equal. Now, 10 is 3 here. Okay, you need the power of 10. 10 to the power of 3 equal 1,000. And then P will be equal 1 milliwatt times 1,000. 1,000 milliwatt or equivalent 1 watt. Okay? You get that? Otherwise, I want you to do for me. I get dBm, okay, equal 10. Converted to watt, watt or milliwatt.
Milliwatt.
Now, try to see, can we do it? I suppose you already get your hand out. Okay, I given you the formula. dBm equal 10 times log of whatever power we can be. They must divide to 1 milliwatt. That is the formula for dBm. And now they say equal 10. So you get 10 dBm.
That's
Okay. Now go ahead and calculate. Tell me what you get.
10. P is 10.
10 what? 10 milliwatt?
Milliwatt.
Okay. So I do the calculation. Okay. So now you can see I want log, right? Log, okay, of P over 1 milliwatt. And that will be equal 10 divide 10 equal 1. Okay, take the log out. Okay, so you can get P over 1 milliwatt equal 10 to power of 1. Equal 10. Okay, so that will be telling you P, okay, equal 1 milliwatt times 10 equal 10 milliwatt. So if you get a dBm, you're able to convert it to milliwatt or watt, whatever we need. If you don't know how to do it, let me know. Okay? Otherwise, I think you'll be okay. Now we go to the next one. Adding 1 dBm to 1 dBm. Okay, you see in here, the note here. Cannot adding dBm to dBm. That means they're not equal to joule, okay? Must change to the watt or milliwatt, then add it. Okay? After you're done, okay, convert it back to the dBm. Okay? So now, how can we do? Add 1 dBm to 1 dBm. What
2
they
dBm.
want? They want to converting dBm to watt or milliwatt first. Okay, so you know the formula. dBm equal, okay, right here. Copy that one. Okay, 10 log of P. Now I say P1, okay? You get 2 power, and that will be equal 1 dBm. So now you have to calculate that one, okay? So, see what you get. You take the log only, right? Log.
-1.
Okay. Of P1 divide 1 milliwatt, and that will be equal 1/10, right? And that equal 0.1. Now you take the log out. P1, okay, over 1 milliwatt equal 10 to power 0.1. Okay, what you get?
-1.
Let's see.
No, it's 10 power -1. 10 power -1.
What do you mean 10 minus 1? Okay, you take a log in here, you get 1, divide 10, right? That's
Yeah,
0.1.
Yeah, it is equal to 10 power -1.
Okay, what you get?
Mr.
So
Pham,
P1 is -1.
Mr. Pham, 10 raised to the 0.1 is 1.26.
Wow.
10 raised to the 0.1 power is equal to 1.26.
1.26. Okay, you say 1.26, right?
Correct.
Okay. So I want P1. What equal? 1 milliwatt. Okay, time 1.26, right?
Yes.
Okay, so basically they will be equal 1.26 milliwatt. Okay, same calculation. Okay, get P2 equal 1.26 milliwatt. Now you add it, okay? P1 adding P2, that equal 1.26 added 1.26 equal. So 1.26.
8.52.
Okay, 2.5 joule. That will be milliwatt. Okay. Now, after you converting to watt or milliwatt, you add it. Now you have to doing dBm, converting back to dBm. So dBm will be 10 times log of 2.52. Equal
4.01.
That's it, 0.4, right? 0.4
No.
times 10, 4.01. That is how. You cannot adding dBm to dBm. In order to do it, you have to converting dBm to watt or milliwatt. Then you adding watt or milliwatt. And finally, you have to go back to dBm again. Any question on this problem here? I guarantee if you interview for remote company in San Diego, they will be asking you. Okay. Now.
So how many people get this?
I don't get it at all.
People aren't getting this.
Can you get that?
Yes, I do.
Okay. Now, if you already done, I want you to add in for me this one. 0 dBm to 0 dBm.
Yeah, 1 milliwatt plus 1 milliwatt, 2 milliwatts plus 3 dBm.
So your answer will be, can you repeat for me your answer? Who done? You have to follow in exactly the same way we already did it.
I know the answer, so I'm not going to say it. Let somebody else.
I think 3 dBm.
3.01.
So you get 3.01 dBm, right?
You can't do it.
Engineers and technicians normally just round it off to 3 dB.
So basically, I just copy that one here. Okay. So dBm can log of that one but equal 0. Okay. Then now you take the log only. I copy that one. Okay. And try to see we just change a little thing here. Okay, 10 log is 0 dBm, and they will be 0. Equal 0. Okay, so that will be 10 to the power of 0 equal 1. Okay, so P1 equal 1 milliwatt times 1. You get 1 milliwatt. Okay, and you adding 1 milliwatt, okay, to 1 milliwatt. You get 2 milliwatt. Okay. And you take the log of 2. Okay, so what you get?
.01.
3.01. That's what the people already gave me the answer right here. That's very good. Okay, so quickly we already run out of time. Okay, you can read that thing here.
Hey, Mr. Pham, could you put that back for a second?
1 minute.
Mr. Pham, can you reduce the fonts and show your whole page there, please? Your whole formula page.
On the up?
Your notepad, can you show the whole formula page and reduce the font so we can see the whole formula for that page?
Oh, I have to make it smaller.
Please. I just want to see the whole page completely.
Let's see. Let's see, that can show. Oh man, too much.
Go to the upper right-hand corner and hit the maximize button.
Yeah, just a minute. I will be changing that thing here to smaller.
Thank you.
Can you get that?
Keep your page maximized so we can do a screenshot. Thank you.
Well, I'm going to take credit for your pasta.
Could you also mute all the mics, please?
Thank you, Mr. Fan.
Okay. Quickly go a little more, then we'll be say for Wednesday. Okay. Also in here, they can telling you, you cannot adding dB watt to dB watt or dB volt to dB volt. You must be changed to watt or volt. You add it, then you have to go back to dB. Same thing like we already did it. Now, a data sheet say that output amplifier is 24 dBm. What is the output power? We already doing calculation for you. And also this is the solution here, okay? I don't need to repeat again. And also data sheet say that the output amplify 10 dBm. What the output power? We already did it for you. Okay, now that is you can get the amplifier. You get to amplify A1 and A2, AV1, AV2. So in order to calculate the total, the gain of amplifier, okay, that's what they're talking about, cascaded amplifier. Then AV will be AV1 times AV2. If you get the first gain is 10, second gain is 10, so the total gain will be 100. However, if you want the total gain in a dB, you cannot multiply. You cannot add it. Multiply, you must be adding. AV1 adding AV2. For example, you get the first gain 2 dB, a second gain 3 dB. The total gain must be 5, not 10, okay? And the last one I'm talking now will be impedance matching. That means your amplifier here, input impedance are in, output impedance are out, okay? Or RL. On resistance should the same. RG equal R in, okay, equal R out or RLR. That means for maximum power, then resistance must be matching, okay? Impedance R in microwave system is 50 ohm. Impedance R in TV, 75 ohm or 300 ohm, depend. Impedance R in telephone system is 600 ohm, okay? So now you have any question. Otherwise, make sure you go over on the transistor, okay? The quiz on Wednesday will be talking about, asking about the transistor and a field for the dB. That's what we come up today. Okay,
Thank you, sir.
Any question?
We fail that.
Hey, Mr. Pham, just a question on the impedance matching. For impedance matching, is that used for like if you're dealing with speakers and different things, or how's that used?
Right. That means that between the output from the system impedance coming out, they're supposed to be matching with the receiver. Like your speaker, okay? You can say your speaker, they be matching with the amplifier coming out. Otherwise, signal will be lost.
Okay, thank you.
There's a theorem about power transfer. When the load impedance equals the source impedance, or the complex conjugate of the source impedance, which we'll learn about later. But when the load resistance matches the source resistance, that's the maximum power transfer condition. And you can actually derive the equation, and we'll do that in our study group tomorrow.
Okay, thank you.
Okay, so good night, everyone.
Good night.
Good night.
Good night, sir.
Yeah, we see you.
Hey,